I'd like to welcome everyone to today's session, Introduction to SQL Server 2005 Analysis Services. I'd like to introduce today's presenter, Kamal Haiti. Kamal is a Product Unit Manager for SQL Server Analysis Service for Microsoft Corporation. And without any further delay, I would like to turn the floor over to Kamal.
Hi, thank you. Good morning, everybody. Good afternoon or good evening, wherever you might be living. And I'm really happy to be here and talk about analysis services in Yukon in SQL Server 2005. Introduction, a little bit more background. So I'm the product unit manager, which means I manage the engineering development of analysis services. For me, this actually is a bit of a new job. I used to be managing integration services, and some of you might have heard me in webcasts and integration services over the last couple of years. So I'm excited about doing this webcast and actually not only introducing myself but also the product to those of you who haven't had a chance to see it yet. So we'll pretty much focus on demos for most part, and then there'll be some slides and verbiage around what we're showing you. Also logged in this webcast today is Rob Zaire, who's a program manager in the analysis services team. And Rob's a super skilled guy, lots of experience. He's written a book on MDX programming, so he really knows his stuff, and he'll be answering technical questions that you might be having. I also will be taking questions toward the end of our presentation, and I will be answering them verbally in addition to the chats. So let's get started. And to give you some context where analysis services fits in, it's part of the SQL Server Business Intelligence offering, and which consists of three essential parts, as you might think about. One is to integrate the data, second is to analyze it, and the third is to report on it. And obviously there's three parts of SQL Server that fit right into this, with the first one being integration services, the second being analysis services, and the third being reporting services. And analysis services in some ways is at the heart of the BI offering that we provide with SQL Server. It's a traditional OLAP, it's data mining, it provides you data modeling capabilities, and general data enrichment analysis. And as such, is a very rich offering that allows you to sort of bind together the central heart of your analytical offering inside the applications and your IT infrastructure that you might have. In terms more of a little bit of background, and this background also helps me introduce some of more of my background. We started off a SQL Server in 7.0 and introduced this thing called OLAP services at that time. I don't know if any of you remember that, but OLAP services was essentially the first time a database vendor provided an OLAP product offering as part of the database. And that was a big deal at that time. People charged a ton of money for OLAP, and we sort of just put it in the product and made it accessible to pretty much anybody who bought SQL Server. I personally actually joined that team in 7.0 way back in '97. That's my background. And I was with the team through 7.0, and then we released 2000, which was somewhat of a smaller release in some ways, but it gave us completeness of the offering. We rounded off some corners. We added data mining. Yet another first where a database vendor included data mining as part of the traditional database offering. And once again, took a technology that is, pretty much in the hands of high-paid lab coats, if you will, and made it available to everybody else who wants to use it on a daily basis. So that was SQL 7, 2000, and then we had this, gap in the middle, if you will, 2000, 2005, 5 years of reinventing this product, and it's a completely different product. If you're used to 2000, you need to sort of rethink how you use it, step back a bit, and really get a handle on it. For me, for example, I left this team in around 2000, went off to do integration services, build that team up, and I came back here in 2005, and it's a completely different product. I am actually still having some trouble here getting my head around the richness and vastness of this product. It's so big that I am still, even though I spent time with SQL 7, SQL 2000, building that product, I'm still learning what's in 2005. Okay, let's now transition over and talk about the product itself, and see where it fits in, what we can do with it. So if we think about it, 2005, SQL 2005, essentially is as I said before, a binding product. It enables you to do analytics over diverse kind of data sources. You can take data from SQL data marts, from Teradata, Oracle, DB2, all kinds of places, and then you create what we call the thing called a UDN, which essentially, if you want to think about it, is a cube on steroids. And if you use OLAP cube, this is a cube, but it's really supercharged. It's on steroids. In many ways, it represents the business logic, the very foundation of your business in terms of calculations, in terms of policies, in terms of even presentation. All of this can be self-contained in this unified dimensional model that allows you to go off and model the business logic, if you will, of the analytics of your enterprise. And then it's possible to go ahead and not only have it available in what used to be traditionally in a process mode where you go off and you build your cube and reprocess it and again build your cube over time. And typically, if you use OLAP systems, they are sort of after the fact. You go off on maybe daily basis or some cases even weekly. You go off and rebuild your cube and then you do slicing and dicing against it. In Analysis Services 2005, we introduced this notion of a proactive cache, and we won't talk much about it in this presentation. There's actually a separate presentation on real-time BI that Paul Sanders will do as part of the series later in the week. But suffice to say for now, we introduced this thing called a proactive cache that allows you not only to do the traditional OLAP analytics and data mining on your data, but have a cache that is almost real-time updated. As a result, you can choose to have either minimal latency on data or go back and have traditional load and run kind of analytics. As a result, what you have is an offering that allows you to get data from many diverse sources, have a unified central model of your data, encapsulate your business logic, have a real-time cache that allows you to go off and do the analytics literally in real time with updated data that's coming from your source systems. And then we expose this functionality via a unified API called XML analysis, which was introduced in 2000 in SQL 2000, a little later there. And XML analysis, once again, we won't talk much about it here, but it's an API that's supported by multiple vendors, including SAS and Hyperion, and SAP BW also uses it. And it's an open unified API that allows many different kinds of front ends to connect to analysis services and be able to take advantage of functionality. And towards the end of the presentation, we'll actually cover a bit more about that. But it goes all the way from traditional spreadsheets like Excel to dashboards to reporting services to all kinds of other clients that can take advantage of this rich functionality in SQL Server 2005. All right, so having said that, in terms of just the overall very simple block level architecture, if you will, of the product, let's go and talk a bit more about the feature set itself, and then from there we'll actually start going and looking at the product itself and do a couple of small demos to make the points. So, moving over, if you think about analysis services, one sort of central tenet that comes out of why to use analysis services is that you, in most business environments, want to be able to have a single version of the truth. You want to be able to have a model that encapsulates your business logic, your data, and it can be a central place where you can go and get the right answer, if you will. The right can have different meanings here, but you want to have a single version of the truth where you can go and do your analytics based upon it. And what that means is you can, as I said before, combine multiple data sources from different places. But not only that, can you have the single sort of big view of the data, but you can have multiple windows into it. You can have different looks for different types of customers, different types of consumers, different departments can have their own view into this single version of the truth that we talked about. And we will actually go in and look at some part of our demo that covers this over and over again. And not only that, but we also enable, via this central model, the ability to be extremely interactive and very quickly, which is sort of the heart of OLAP, to go ahead and interact with the data in a visual environment such as using a spreadsheet or a portal or those kinds of things. And last but not least, as I said before, any third-party application that supports XML analysis can take advantage of all these features, can take advantage of connecting to the single version of the truth, the single model that unifies your data, and then do analytics against it. Having said that, what I want to do next is actually move on over and do a little demo that shows you the environment we use to build these models, these cubes, as they are, and then walk you through the process of actually building one yourself, and then talk about these features. So I'm going to click on my sharing slide, and my advice to you is that you should go click on that little icon below attendees that maximizes your screen size so you can actually see the full screen and can follow along the demo. Otherwise, it's sort of dense and hard to follow at times. Okay, so I'm going to go ahead. I'm going to go ahead and click on my start page here. What you see out here is Visual Studio 2005, and I have here just a start page of what's called the Business Intelligence Development Studio. And basically, it's a specially modified version of Visual Studio with special project types that are suited for doing BI development, for doing analysis services development, integration services, and reporting services development. And I will now go in and say File, New, create a new project, and it'll be an analysis services project, and I will give it a name, something like Webcast 1. Go ahead and say OK. And what I get after doing this is a solution with different artifacts in it that are part of my solution, like a data sources, data source views, cube, dimensions, mining structures, roles, assemblies, etc. Right? So we'll go through each one of these and go ahead and create different parts of this. So first thing you need to do is to create a data source. And a data source is essentially the connection to data you want to use. And so a wizard pops up, nice and friendly, and we're going to use throughout this presentation the AdventureWorks data warehouse data. And this is part of the samples that come with SQL Server 2005. And if you haven't installed it, I really encourage you to go ahead and install these samples, because it's a very rich data set. It's got information, relationships, both for OLTP type applications as well as data warehousing, OLAP, data mining, reporting, integration. Everything's built in. It's very well thought through, and literally one could end up writing, if you wanted to, a couple of books on just this data and get insight into how to use it. We'll just use this today for our demonstration purposes. So you go ahead and say next, and then I'm going to use service account, and I'm done building a data source. The next thing I want to do is build what's called a data source view, or a DSV. And a DSV is a brand new concept in SQL Server 2005. And what this thing does is gives you, in a sense, an offline representation of your data, a view into your data that you can use to go ahead and build your cubes and, in fact, your integration services connections, even your reporting connections. And you, with the DSV, get the ability to go and define independent, in a sense, of your cube, the data and its relationships that you care about and want to work with. And we'll look at some of that. So if you look at our tables that are available in AdventureWorks, has many of these. And if you're not sure what to use and how to go about, I, for example, am interested in sales data. So I'll go ahead and filter by sales. I type in the filter sales, and I have this funky funnel icon that's supposed to go and do the filtering, and it does it actually. And I'm going to pick up some of the tables that I need, and I'm going to go around the things that I'm interested in analyzing. And these happen to be the internet sales, they happen to be my reseller sales, and they happen to be my internet sales reasons. And these are sort of are connected together, and we'll see how. I'll go ahead and select these, and what I'm going to do is add related tables. So this is kind of interesting again. So analysis services is smart enough to go ahead and find all the other tables that are related to these central tables that contain the facts you want to analyze. And it goes ahead and finds these other things, sales reason, time, reseller, promotion, etc., which if you are kind of OLAP savvy, you say, oh, these are dimensions, and that's about right. So we go ahead, say next, give a name to our DSV, and finish. And when you're finished, what we see is this very interesting schema. It's a rich schema, as you can see as I'm slowly scrolling over it. You have these different kinds of tables, self-referential tables. We've got these fact tables that relate to each other, dimensions. And it's not your, yesterday's star or snowflake schema. It's much more connected, much more related together. There are many relationships. And we can actually go off and work with this now in 2005. This would not have been possible to do in SQL 2000. And for that matter, with most OLAP tools out there, it's very hard to actually go ahead and do these kinds of things in any meaningful fashion. So what we'll do next is a couple of things. One, I'm going to show that you can take this, as I call this, offline representation, and you can actually add something to it. You can add to it some information, if you will, that's not present in the backend schema that you got the data from. So for example, here we have the customer table, and the first name, middle name, last name. But let's say we wanted a full name, right? We don't have a full name in the schema. We won't add it, but you don't have access to the backend. You can't go in and mess with it. There's no DB available. What you say is you just go right-click on the schema here, on this table here, and say new named calculation, and up pops this dialog, and I type in the name that I want to give this column, and I will call it full name, right? And I will give an expression to it. And it's a very simple grammar. I will type in essentially first name plus space last name. And I should make sure that they actually are the right column names, and indeed they are. I say OK. And what you see is I've added this little calculator icon next to it, a calculated column called full name. And this calculated column has been added in the DSV, in this offline representation of the underlying schema. We have not changed anything at all in the backend database, right? So now let's even take a look at this. We can go in, we can click here and say explore data. And in explore the data, it retrieves the data from the underlying database. You can see here all these different things. And scroll all the way to the end, you find the full name. And the full name actually is first name space plus last name. And bingo, by magic almost, it goes ahead and gets this information back for us from the database. It's an interesting concept here, and you might want to do more than maybe just do first name plus last name. But typically, it gives you the ability to work with these sorts of calculations aside from the backend. Let's say we go and take a look at something more interesting information here, and we want to go look at something to do with products. Let's say we go find here is a product table, and I want to go explore this one. Now the explore data part not only allows me to look at data in terms of these sorts of tables. So you can see you have this different English product definitions that go all the way from whatever names of bikes to other kinds of things. And I can actually go and do a pivot table on it. Go to the pivot table, and here I can say I want to take a look at the English product name we saw before, and the names of different things. I want to say, for example, I don't know, list price, right? And drag that in. And what we see is that some things don't have list prices in it, and that kind of makes sense. I have ball bearings, which I use for internal manufacturing, and I've got chain stays, or I've got decals. I don't sell these things, so I don't have any prices for them. But I do need to reorder them, for example. So I go in and look at here, I can see I have different reorder points for all these guys that I can take a look at. So I can have a different sort of idea to looking at my data in sort of in a pivot table kind of fashion. I could have added in the different columns here and pivoted with it. But the point being, I can actually look at my data, understand it, even before I go off and do any sort of real multi-dimensional analytics on this. I can explore the data in a rich fashion. Not only can I do this, I can go back, for example, and click here on the chart tab. And here I can get an idea about different sorts of relationships between my pieces here. How much time to manufacture, what's the end date, what kind of class I'm working with. I can go to things like pivot chart, and here you can see it's really dense because I got English product name which is too big. I can go and uncheck these guys and only pick up names of real bikes, maybe and we had these road frames, black and whatever it is. I click all over the place. I get a few of these, and now I can actually see these, and I can say, you know what? What if I want to know different stock levels for these guys? I try and drop them in here, and you can see some of stock levels for these different types of bike frames. Anyway, the point I'm making is you have some very interesting and powerful tools to model your data, your schema, before you even start using it for actual analytical purposes. All right? Great. So this is what we did with our DSV. Now we have a data source. We have an offline representation of this DSV, a schema that we have annotated, enhanced with adding some calculations to it. Now we want to go off and actually build this cube, this actual UDM model that is the heart of our product. So once again, a quick clarification. You'll hear the words UDM used as a unified dimensional model, which is sort of the model of the data. It includes the calculations, logic, and all that I talked about. Just think of it in real terms as a cube, as a multidimensional representation of data, but it's much, much more powerful than any traditional OLAP cube you might have used in the past. Okay? All right. So I go in, right-click on this, it's a new cube, and I come to the cube wizard. The whole product is driven by wizards, and that's same as our legacy we had with SQL 2000, SQL 7. Our goal really is to enable anyone who wants to use technology to be able to do it without having to know the arcane details about how to do it. And you'll really see how we do this in 2005, really up it a notch, if you will, to quote my favorite chef. Okay, so welcome to Cube Wizard. Say next. Now we can build a cube by different ways. We can do it either in an auto fashion. Literally, we will, in a one-click, guide you through building a cube. Or you can go in and literally build a cube, not bottoms up from the data, but top down. You can go in and say, you know what? I don't really know what data I really have right now, but I know what measures I want to use, what dimensions I want to create, and you can actually model your cube without having the underlying tables ready, and go off and define the dimensions and what members it's got, define the measures, the fact table, if you will, and then analysis services will retrofit, will create the schema in the back end to fit this cube design that you have created with the sort of top-down approach. We even, to add with that, we actually provide you templates. And these are sort of predefined schemas that you can go and start working with and modify. And we provide a couple of templates out of the box, but you can build your own template. You can go build a cube, take the cube definition, there's a files that make up the cube definition, and put them in a templates folder that's in our directory. And lo and behold, those templates will show up in this wizard the next time. So we provide you this reusable templatized approach as well. A little bit more advanced. I will stick to doing it the auto way. Click on the radio button up there saying, auto build it. Here too I have a couple of options. I could have said create hierarchies or attributes only. And it's a subtle difference here. And it hints at a very interesting change that's come up in 2005 from 2000. And I will talk about it more as we go further on. So I say next. And I'm going to use my DSV that I already have. And you see this right now it's analyzing fact and dimension tables. And this wizard, this cube building wizard went back and analyzed relationships between different tables. What kinds of outgoing, incoming relationships are there? And typically, for example, it says if a particular table has many, many outgoing relationships, it's most likely it's some kind of a fact, some kind of central fact holding table has numeric information and many foreign relationship keys that are used to connect it up to different dimensions. And that's one way you can figure out what sorts of tables, types of tables are there in your schema. What are the fact tables? What are the dimension tables? And it analyzes, auto-analyzes your schema to suggest to you what it, in this case, the system believes are fact and dimension tables. As you can see out here, I've got internet facts, reseller sales. I've got internet sales reason, etc., etc. I've got different kinds of tables here. Some of them are pure dimensions, as you expect. Currency, employee, product. These are pure dimensions. All those are interesting. You've got things like internet sales. It's both a fact and a dimension. Kind of strange and different. Another new thing introduced in 2005 is the ability to have this sort of a degenerate, if you will, kind of dimension. It can be both a fact as well as a dimension table, and can participate in different ways based upon how you want to use it. So out here, I'm going to take most of the recommendations, except I don't want to use reseller as a fact. I'm going to uncheck that. And so now I have the 3 fact tables, rest dimension tables, and I also have the choice of picking a time dimension table. In other words, I can tell which of my dimension tables is geared towards doing time intelligence. And that's very important because most analytics deal with history. You know, who only bought something, but when, what trends were there, how they changed over time. So that's important. So I'm going to go ahead and pick, obviously, dim time, which sounds like a good name as any, as a time dimension table. Say next. Then I'm asked, hey, which of these columns represent year, half year, quarter, etc. And I'm going to go all the way down and find, in this case, calendar year, which sounds like a good year column. And I'm going to pick up, this is a tricky one. Robert here give me some hints here. Calendar semester. To me, semester is to do with colleges and stuff like that, but semester is half a year. And not being a native-born English speaker, I had trouble with that one, but I figured it out. Then we've got quarter, it's calendar quarter, and I've got my year, half year, and quarter mapped in to my time dimension columns, so I can go ahead and use this as part of our model. Done. Now I'm showed these things called measure groups. That's another new concept. Now measure groups, to me, internally are mapped in my head as fact tables. A fact table has multiple facts in it, and a measure group has multiple facts in it as well, fact columns in this case, right? So, for example, a measure group out here called internet sales, we've got, unit price and amount and sales amount. These are all different kinds of counts. If you've got, again, I've got reseller sales in another group, and I've got things like, a tax amount, sales amount, etc. But it turns out that a measure group is not necessarily just stuck to one fact table. A fact table can be actually participating in multiple measure groups. And it's a bit of a more complex relationship than just going by the one-to-one mapping. But it helps sort of get your head around this fact that now we group measures together in things called measure groups and then roughly map to fact tables. Not exactly. You can have more complicated relationships, but for now, we'll just go with this. All right? Okay. Pick our measure groups, and then the wizard now is examining the relationships within the dimension tables to figure out hierarchies. Literally, it's going to scan up to 100,000 rows to figure out how are these different dimension tables related. What are the hierarchies that are present? And there's an interesting difference now coming up as opposed to SQL 2000. So it's finished doing its detection hierarchies. If you go look here, you've got these dimensions here, and we're going to look at time, for example. And you've got two things here, hierarchies and attributes. With attributes, there are different attributes, calendar, semester, quarter, etc. And then with the hierarchies, we've got the hierarchy of year, semester, quarter, which makes perfect sense. But the interesting thing to note out here is that these attributes that we have that are part of the dimension can participate in different hierarchies. I could rearrange these attributes to create different hierarchies. And that's a big difference from 2000 in that in SQL 2000, if you wanted to create a different hierarchy, you create a separate dimension table, and then you gave it a sort of a different name with a dot in it or whatever. So whereas in SQL 2005 now, with attributes, you essentially have a dimension that is made up of a flat list of attributes, and then these can be rearranged and exposed as different kinds of hierarchies that we want to use. And we'll actually look at more of this as we go down further in the demo. But it's a big change in many ways, and has many implications for performance reasons as well. I will talk a bit about this as we go further down. All right? So it went in, the wizard by itself found which tables are your dimension tables, which are your fact tables. It found multiple different types of possible hierarchies in your dimensionality, and all of this it did by itself. Now, note, I could have pressed this finish button it was available to me throughout the visit. Any point in time, if I click finish, the wizard would have finished, created these structures for us, and given us a ready-made cube that we could work with right off the bat. Literally, in 2 clicks, you could have gone from starting the wizard to having a fully built up cube with relationships, dimensions, measures, hierarchies, multiple measure groups, etc. Very powerful, I think, in my opinion. So here we go. I say finish, and we now go ahead and actually create the structures we talked about. Here we are with our schema for our cubes. Now, if you look at the schema here, and once again, it's an interesting and somewhat complex schema. It looks like a DSV somewhat, you might think. But it's not, again, your simple stars or snowflake schema that we had before. And here's an interesting little piece to look at this one. You have 2 of your yellow boxes, and they're essentially 2 fact tables. And then you have a third one up here. And between these ones, the sales reasons and internet sales, there's this thing called dimension sales reason. These essentially form what's called a many-to-many relationship between these facts. You can have multiple sales and multiple reasons for sale, and they relate to each other in different ways. And that's, again, a significant shift from SQL 2000. Also, the fact that you have these multiple fact tables, right, 2 here, I said, and then 1 up here, that is also a significant shift. And in this case, we are combining 2 kinds of sales together. Think about it. We have sales from resellers, people who actually have employees and are selling your in some kind of a store maybe. And then you have direct sales that are taking place on the internet. Both these kinds of facts are combined together in one single model, in a single cube. This, again, is a significant shift from analysis services in the past, where typically in the past out there, we had multiple cubes defining these sorts of different types of analytics, and we could combine them together as, say, virtual cubes. Whereas now, we put all this information together in one single model. A single model has got both, in this case, reseller-oriented facts, as well as internet direct sales-related facts. And both of these can be combined together and work. And we'll go down and see in subsequent demos that not only can you do that, but then you can actually have different views, different looks for different applications at these kinds of data and work with them. All right. So having said that, what I want to do next is talk a couple bit, a few minutes more about attributes and hierarchies and how they work and give some ideas there. The first thing I want to do is go look at one of our dimensions, and we'll take a look at, let's see, what should we look at, Robert, do you think? We'll go look at date, look at due date. But before that, I want to actually see usage of my dimension. Well, let's look at due date. So we'll go look at due date here. The funny thing you might notice here by the date dimension is that we got ship date, due date, as well as order date, and we have one thing called dim time. And so these 3 dimensions actually are playing a role playing these different types of dimensionality, and they're all based on the same dimension, which in this case happens to be the time dimension. So I go in and click on this and see it says edit dim time, which is what it's based upon. And up comes my dimension structure. And here you can see my hierarchy we talked about, the year, semester, calendar, quarter. If I want to change this hierarchy, let's say I want to add in days below the quarter, I can just go in and find day number of months, for example, out here, just drag it and drop it, and lo and behold, I have a different hierarchy that's built up right here on the fly. You'll notice as I do this, it adds this thing called day number of months to the list of attributes for this dimension. So now this dimension has got, instead of 3, it's got 4 attributes. And these 4 attributes combine together to form this hierarchy. Now, I could have gone ahead and built a different hierarchy. I could have said a day number of months, for example, and then as I add this, the number of months already exists, so it's not added to my attributes. And then I could have gone in and added, for example, week number of year, and put it on top of this. And you can see when I add that, it gets added to the list of attributes. So now I have these attributes that compose my dimension. They can participate in different hierarchies and get exposed as different hierarchies in my cube. And that is a fundamental shift, if you will, from 2000 to 2005. And it allows you to have a very flexible dimension structure that can literally be recomposed, re-put together for different sorts of hierarchical structures for your analytical applications. The thing to be very, very, very careful about here is you can actually have, you can say, oh, you know what, I want to have all kinds of attributes in here just so maybe I can use them later sometime. I want to go ahead and keep day, month, and week, and year, and quarter, and semester, and everything in my time dimension. And then maybe afterwards I want to go ahead and create a new hierarchy based upon fiscal quarter, a new one based upon something else. The trouble is, the more attributes you add to your dimension, the more you add to the join that you're going to create to create the cells for your cube as you go ahead and actually do that analysis. And what that means is, if you have a huge list of attributes, you will end up having a humongous cell space that you need to go ahead and traverse and calculate against, and that can impact the performance of your application. So be very careful when you go ahead and design for flexibility versus performance. Again, this is not the scope of this presentation, but you must understand that there is a trade-off when you go off and try and be extremely flexible. The more flexibility you go and add into your system, the more likely somewhere down the road you'll pay a price for performance. Obviously, it doesn't mean that you should keep it rigid. It just means you've got to be aware of what is involved, what is participating in your cube as you build it, what in your structures, and what your ultimate resulting cube space is going to be when you go ahead and actually do the calculations against this data. Just keep this in mind as you work with it. Okay? All right, I'm going to close this down. This particular view is going to say to save it. I'll say no, discard. And I'm done discarding this. And if I go look at different things here, you can see this is, again, my schema as I had before. And if you look at my fact table again here, which we got. So what I want to do next is switch over to my slides, and we'll talk about some more parts of our system here. So let me switch over, and I'm going to go and return back control to my slides, and we will go to slide number 9 here. Okay, so we talked pretty much, if you think about it, we talked a lot about the structure, if you will, that you can build to represent this one version of the truth, this unified dimensional model, this cube that we talked about. We talked about having dimensions, measures, of having different kinds of attributes that build hierarchies. The DSV, which we looked at, the data source view, which is sort of the underlying foundation to build the cubes on top of and actually represent your model from a schema perspective. So we talked about all these kinds of things, and we saw the interface that we worked with to go ahead and get an idea for how to go ahead and create a cube. One thing I should have added is that once you go ahead and create this kind of a cube that we saw before, what you need to do then is actually go ahead and deploy it, which means you go ahead and you have to go ahead and take this offline definition, which is essentially an XML file, and ship it off to the server, and go ahead and on your production server, test, or your development server, recreate these structures for use by multiple users. So there's this model, if you will, that you use working in Visual Studio. You're working in this development environment that is disconnected from the live version. And when you go ahead and ready to go ahead and deploy, you actually do a deployment that, if you think about writing source code, there's a compilation, and then ships off the manifest for what you want to go ahead and be your ultimate system to your live server that you can go ahead and work with. Okay. Anyway, we'll talk a bit more about that as we go further. So, having said that, the second part, if you think about analysis services and what it provides, and sort of the heart of the beast, the machine, if you will, is this notion of data enrichment and analytics. And it says analysis services after all, so the thing that you do with it the most is work with data, do calculations on it, and go ahead and find your trends, find your exceptions, etc. And so we can encapsulate advanced business logic, rules, and calculations as part of the dimensional model, as part of this cube, and you can go ahead then and use in your spreadsheet, in your other clients, and actually do the slicing and dicing and find trends, etc. We also introduced this thing called key performance indicators, and we'll take a look at them in the demo that I'll do next. And these KPIs, essentially, we can think about them as surround views, 360-degree views of your organization. They provide metrics that are important, strategic metrics that you can define to keep track of things that are happening in your organization and you can work with. Okay. We also have data mining, which is really important, obviously, real-time analytics that we'll talk about later on, etc. So I'm going to switch to a demo again because I think we have about 15 minutes left for our presentation, and I don't want to shortchange your demos, and I think those are more interesting than these slides. So I'll go ahead and I'm going to click on my sharing slide again, and we will switch over right now to another project that I have. And this project happens to be a pre-built solution that this exists inside the installation of 2005 that we have, and it's AdventureWorks solution. It's part of the samples, it's analysis services samples in the SQL program file, SQL Server tools. Then there's a little samples directory. You can go find this. And this is an interesting cube that we pre-built and provide. If you go traverse it, it's much more complicated than what I had before. It's got multiple fact tables here, multiple complex relationships, and it's got a ton of logic built into it that we can use to go and understand and work with these different things. So the first thing I want to talk about is this notion of translations. And that's yet another brand new feature that we introduced in SQL Server 2005. And if you're a global company or a global ISV, or for that matter, somebody who works in multiple different languages, you might be living in Switzerland, so you work with French and Italian and German, or you'll have to live in Miami and you're working with Spanish and English. It doesn't matter. Or heaven forbid you're from India and you've got like 35 different languages to contend with. But either way, the point being, multilingual solutions are really important. And we provide to you an ability to go ahead and provide metadata translations of the objects that are in your model, in your cube, and then which are then rendered in this translated text when you go ahead and actually connect, and your client says, the connecting client says, oh, I am a, take a pick, French client or Spanish in this example, and then all the metadata then is translated in that particular language for display. The way you do it is you go to this tab in your BIDS, in your BI Development Studio, where your cube's been defined, and you find that we have a place where you can have caption definitions for different kinds of objects. So measures are translated here, for example. We go further down, dimensions, and we talk perspectives in a second, KPIs, etc. we said before. And here we have two different translations, one in Spanish and one in French, and you can see that different translations exist for both of these guys. And we have about 130 different languages that are supported by the Common Language Runtime in .NET, and the same ones are available in this particular translation facility that we provide for our product. So what I want to do is go back to my cube here, and I want to go and take a look at my product dimension. So I'll go find my product dimension, I'll double click on it, and what I find here is this has got multiple attributes. You can see out here, this one is rich, many different hierarchies, many more than I talked about before. You can see the point we made about hierarchies and the fact that these attributes combine and participate in different hierarchies out here. And I click on the Translations tab, and what you'll find here is that for this dimension again, each of the attributes have their own metadata translation. Not only that, but you find little things here which have got their own little icon. For for example, producto, I'll click on that, or categoria. And I click on these ellipses here, for the French one, for example. And what I can do here is I can point to a separate table for the captions, a French translation for the caption that you can do and provide yourself to go ahead and provide much richer translation of the members that constitute this dimension here. And you go ahead and actually look at it as you browse, and you'll see that you've picked up these translations from an external table that you can provide for your particular needs and work with them. And you can all not do that, but define different sort orders, accent sensitive, canal, case, etc., different collations. So it's very rich in terms of the ability to go ahead and define translations that you can work with. So enough of showing this sort of how we set it up. I'll switch over now, go back to my cube definition, and I want to do is browse my cube. I want to go ahead and look at it and see how this translation shows up. So here I have is the cube browser. I go and pick up some measures, in this case internet sales amount and ratio to all products, I'm told, more important than just parent products. And then I want to go ahead and look at the categories I can work with. In this case happens to be product categories. I'll put them here. And then I want to go take a look maybe at customer geography. I'll go find the customer. Here it is, customer geography. I'm going to go and put it on my columns here. So I have an interesting view out here. I can go click and I can say expand all items here. And you can see I've got, bikes, bike racks, bottles and cages, etc., etc. Internet sales amount. It's all English. No language stuff here yet. So how do I get the translation? Let's say you're a client, you're, the new version of Excel, let's say, or Panorama, whatever is ProClarity, or the new tools, new versions of tools that are, built for SQL 2005. And those clients would know how to make a request of the server and say, you know what, show me this data, this metadata in a different language. In this case, we're going to go and find the French definition, and we're going to go and scroll all the way down to tons of these, Dutch, Netherlands, Dutch, Belgium, English, Belize, Canadian, Ireland, Jamaica, New Zealand, blah, blah, blah. Further and further and further until I get to the French France, which I find is kind of funny actually. It's like English, England. What else would there be? Anyway, I click on French France, and hourglass comes up, and something very interesting has happened. Everything has sort of translated itself. Right here, the measures have become, clients of the internet, or accessory, or below, or it's all in French, and I can honestly say it's all French to me. And you can figure out here as you scroll through regions, the actual, if I go and were to expand all these out, the actual definitions of each of these items picked up from the tables. Remember, we pointed to the different tables that we want to pick up. Picked up the caption and attribute translations, and we got different things translated in different language now. Anyway, see on rouge, noir, all French stuff, and this is, I think, it's very powerful. And this really drives home the fact that this is not just, a traditional cube with some simple or for the matter complex calculations, but it's encapsulating some fundamental logic of your business. How do you name things? How do you go off and display them to your customers? How do your customers interact in different parts of the world with this? The entire sort of globalization of your logic is encapsulated in this unified dimensional model. It's very, very powerful, and this simple feature actually, to me, drives this home in a very interesting sort of way. Anyway, I'm going to switch over to yet another interesting demo, and I'm going to do this in French, even though I don't speak French. I'll do it in French. So I've got all these things here, accessories and nom de produit, whatever it is. And you see up here this notion of thing called perspective. You see this here? And remember we said we had multiple fact tables, and in the example we had both reseller as well as direct sales, and there could be different kinds of people who want to use this kind of data. So think about a unified dimensional model, this cube, as being an all-encompassing model of your business. You are including in it different kinds of facts that may or may not be relevant to all your users. So what you can do is define windows, define views onto your data that are called perspectives. I guess where the name Vista came from, huh? Anyway, the perspectives And you go in, and you can see in here, I have different perspectives here, different kinds of things. I'm not entirely sure what these ones mean actually, so I'm going to be guessing here. But I can guess that the word direct is something to do with direct sales. So I go click on direct, and what will happen is you see suddenly I have narrowed down what I'm working with. And we'll look at my measures. I'm working with internet, everything direct orders on internet, and not working with resellers, not working with employees. But I've narrowed it down to direct sales model. Similarly, if I would go back and look at the other kinds of perspective, I get employees showing up suddenly, and I got different kinds of sales showing up. So I can change the perspective that I provide onto my cube by this notion of perspective. I think it's extremely powerful, enables you to go off and create a very flexible model of your data, of your business, and then depending upon which constituency wants to use it, which customer wants to use it, you can provide them different views and perspectives that they can work with. Important note: this is not a security mechanism. If people have access to the data, they can still get to it. And that's a different mechanism. Security is a different mechanism we provide. But this is more of a presentation mechanism. It allows you to go off and present the model in different ways. Another point of warning again, it's very, very tempting to build this giant model of cube with billions of perspectives and then try and hone in on them. Trouble is, the bigger you make it, you will sacrifice performance at some point. So be careful. Choose your battles wisely in terms of where you draw the line flexibility versus performance. We provide you the tools, very flexible tools, very powerful tools. At the same time, a chainsaw can be dangerous if it's near a foot, so just be careful, right? Anyway, I need to switch over quickly to one more thing that I want to show, and these are KPIs. And KPIs are very powerful. What you have in KPIs is the ability to define, I said, strategic metrics before that allow you to measure how your enterprise is doing, what your progress is, and get a view on those key performance indicators that you are interested in. So KPI, key performance indicators. And we can define in this KPI organizer different kinds of KPIs. We have one that's expense to revenue ratio. We define it up here. We define the associated measure group that gives a dimensionality that you want to work with. And here we have sales summary. And then you say, okay, what am I measuring? In this case, I'm measuring the expense to revenue ratio. It's a measure that I've defined and calculation on the measures I defined earlier. And then I have a goal I'm seeking. Now in this case, a simple goal I put in is 0.25, which is a fixed number. So it gets our head around it. Typically, you might have a dynamic goal. It may be, ratio of expenses to revenue ratio to my global last year's goal, 34 times something else. It's a much more dynamic calculation. For demo purposes, we just keep a simple number here in the goal expression. It can be a very, very complex expression that you have for a goal. And then we say, hey, I want to go ahead and define different. How am I doing status-wise, good, bad, and different? I can define a suggested graphic that you might want to display, and in a minute see what that means, to say your status. In this case, a gauge, so all the way good, bad, red, green. A trend, up, down, or not, and you can see here this trend calculation that tells you it's using the date, the fiscal year, and the calculation on the date out here. And so we have defined these KPIs, we defined how to calculate them, and then we've defined also how to display them. What does that mean? If I go in this tab here, the browser view, what you see is the KPIs showing up in this nice graphical fashion. Growth in customer base is up, good, the good thing, the trend is sideways maybe. Here you can find different status, stoplights, different things are shown. And going back to our expense to revenue ratio, you can see we have got this little green gauge thing giving okay there, and downward trend. And the important thing is that these KPIs are available again to any client who connects to SQL Server 2005. New versions of Excel, for example, will be able to interpret these KPIs and show them. And they will show the graphic that you suggested should be shown. So once again, you're encapsulating not only simple calculations, but logic of display, of interactivity. It models how you want your application, your business application, to be seen and worked with. Very, very powerful, of course, very new. One more quick point I want to make here. is that all these things, for example, perspectives or KPIs, they look to the client applications in terms of things understand. For example, perspectives look like cubes to the calling applications who don't really know what perspectives are. They just like different cubes to them. And it's very important. It's very important for backward compatibility. So you can take any existing front end and connect with SQL 2005, and it won't choke and say, "Oh, I don't know what a perspective is." It will say, "Oh, it's a cube," and look and work and talk and act like a cube. So it must be a cube, and displays a cube for you. All right. I think we're running out of time on demos. There's a ton of more things to show, including data mining, which really I should have shown you before, and I feel terrible that I haven't. If you look down here, if you look at these mining models out here, for example, the targeted mailing, we have defined the mining structure, the different mining models we can use, decision trees, clusters, base, neural net. We have added all these new models that were not there before, I think 6, 7 new ones in there. And you can go view the mining model, and what it tells you basically is you view the model, in this case, is predicting what kind of person is, what factors influence buying of bikes. And it turns out that the biggest thing that influences buying of bikes is the number of cars you own. Duh. I think it's a funny way, though. It's not, if you don't have any cars, but it's like the more cars you have, the more likely you buy a bike. It's kind of a strange sign of our times. And then you can actually go ahead and look at the decision tree, which I'm not going to talk about too much. Look at this dependency network, which actually tells you that bike buyers are influenced by all these different things. And as you go and move these links, the strongest links will survive. And we go away from education, we go away from house owner, we go away from children, we go away from the distance. As you go down further and further, all that's left, the most strongest influence to buying bikes are age and number of cars owned. And ultimately, last man standing, number of cars owned is the prime influencer for buying bikes. Again, I'm flying through the data mining demo. There's a whole different presentation that Jamie McLaren is going to do on data mining, much richer, much more detailed. It deserves its own little session. So please make sure you come to that and see it. Okay? All right. We will switch back to our slides, and I'm going to go back to where I left off and talk about a bit about real-time performance. And it's important to understand here the fact that this model, this cube, can be a traditional what's called MOLAP. It's multidimensional OLAP structure on its own, offline, if you will, that you can connect to and do a slicing and dicing, do analytics. Or you can use this notion of a proactive cache that allows you to go ahead and all the way from being real-time alive, if you will, and connected to your back-end data, to being offline, you can control what latency of data you wanted to work with, and it enables you to go ahead and have this sort of real-time experience with your data. There's another session on this. Paul Sanders is going to do a real-time BI session that will cover this in detail, so I'm not going to talk about this too much, just that this is another brand new, very powerful, slick feature of analysis services in 2005. Okay, I will skip any demos that are related to this one, and I'm quickly going to touch upon the fact that we've added not only lots of new sort of features for calculations and modeling, those kinds of things, but many new things for the manageability and reliability of the product itself. We've added in new security mechanisms in terms of by default, out of the box, something that disables, and you have to go and actually do the enabling from the Surface Control Manager. We've added in manageability features, integration with SQL Server Management Studio, and so the whole approach with enhanced backup, with manageability tools, is for more for 24/7, year-round operational enterprise, and not just geared towards doing, slick analytics. Again, we don't have too much time to cover this, and again, this deserves its own session in its own right, and I encourage you to go ahead, explore the products some more, read some of the books online, and get an idea of some of these new features. As we wrap up, the thing to understand is, as I said before, not only can you connect with different kinds of end user clients, but there's a whole number of clients that today can connect to analysis services in 2005. Downstream versions of Excel, 2003, XP, etc., can connect to XML, via XML analysis and OLEDB for OLAP to analysis services, report services, report designer, report builder. BizTalk works with it, Visual Studio. There's a whole list of people out here, third-party vendors, who out of the box from analysis services work with SQL Server 2005, and then the new version of these products coming out with Office 12, for example, new versions of Pro Clarity, new versions of Panorama that take advantage of these new features of KPIs and translation and all those new things that you saw, and actually support them in a very rich fashion in their new tools. So once again, if you're looking for tools to use, many of these providers provide them. So wrapping up, benefits of using this unified dimension model, this new sort of cube on steroids approach. You saw it's a rich end-user model, can't stress that enough. Support from lots of different tools, very powerful calculation engine. You can have multiple data sources, security obviously, and then you can do, the scalability has been pumped up quite a bit, as you can see, with this notion of attributes and perspective, and being able to have multiple fact tables in your cube design. Little word of caution there, of course. You have to be careful in designing your UDM, your cube, to be sure that you are doing the right trade-off in performance and flexibility, and make sure you do the right thing there. Last but not least, wrapping up here, the last important slide, if you will. Remember, it's not an all or nothing solution. SQL Server comes with a very rich relational database engine, and there are times when it makes perfect sense to think about relational database-based reporting, use reporting services, for example, directly against relational database, and there are things that you are worried about, sort of arbitrary queries that don't fit your predefined model. You want to be real-time against the OLTP system. There are things like full-text search you want to use. Your schemas are unwieldy beyond even the capabilities of analysis services, and then, of course, for update-intensive applications. So make sure you do a right trade-off between what it is that you want to do in terms of modeling and rich calculations, and that which is much more geared towards OLTP, real-time type systems. We provide everything in the box with SQL Server 2005. It's not just a one solution that's available. Okay? So much for that. We went through these things we talked about. I encourage you to go ahead and actually try this product out if you already haven't. Feel free to send us questions. If you need more information, you can go to these sites, SQLServerAnalysis.com and datamining.com. And then obviously I have a blog which I haven't been keeping up with, but hopefully after this session I will. Send mail to me, kamalh@microsoft.com. More than happy to answer any questions you've got. If I can't answer them, I will pass them on to other people. And then we are still online. You can ask more questions if you want. And I will now be concluding this webcast because we are over our time. And I hand it back over to the host of the session. And I thank you all for the time you've given me, and I apologize for going a few minutes over, but I do hope the session was worth your time.
Okay, and thanks, Kamal. And remember, for more information, you can print a PDF of today's session. To do that, you can go to the File menu in your navigation bar. Also, I'm going to be posting a survey here in just a moment. If you take a minute to fill that out for us, we really do appreciate any feedback. Also, for any upcoming webcasts or any previously recorded webcasts, and for today's, you can go to www.microsoft.com/webcasts. And if you have any content ideas, you can follow this link here. We'd love to hear from you if you want to see something we haven't shown yet. Today's webcast was presented using Microsoft Office Live Meeting. You can get a free 14-day trial by visiting this link here. Also, for filling out the survey today, you will be automatically entered in to win this 40 gigabyte MP3 Windows Media Player. Gives you a little incentive to fill that out for us. And here is the survey slide. Please do take a moment to fill that out for us. We will be sticking around a few more moments to look at the questions and answers if you get those in for us. We'll be answering those via text. I just would like to thank Kamal for presenting, and also thank you to Rob Zaire for answering the questions. We had some good ones come in today over the queue. I'd like to thank the audience for attending today's webcast. This does conclude today's TechNet webcast. You may now disconnect from the audio portion of this presentation.